The cortex is made up of millions of polypeptide chains, cross-linked by three types of side bonds: disulfide, salt, and hydrogen. Side bonds are responsible for the elasticity and strength of the hair. Altering these side bonds are what makes salon services possible. Hydrogen bonds are weak side bonds. They are easily broken by water, and reformed when the hair dries, such as in wet set styling, or they can be broken by heat, and reformed as the hair cools, as seen in thermal styling. Although individual hydrogen bonds are very weak, there are so many of them, that they become strong enough to account for about 1/3 of the hair's total strength. You can compare hydrogen bonds to spaghetti noodles. A single noodle is quite easily breakable, but the more noodles you try to break at once, the more difficult it becomes to snap them in half, yet, it is still fairly easy to do. Salt bonds are weak side bonds that are easily broken by changes in the hair's pH. They reform when the pH levels return to normal. For example, the pH level of the hair is generally 5.5, and the pH of pure water is 7.0, so by applying pure water to the hair, you have changed the hair's pH level and broken salt bonds. Shampoos, conditioners, and other chemicals will all change the pH level of the hair. Even though there are more hydrogen bonds than salt bonds, they still account for 1/3 of the hair's total strength. Just as we compared hydrogen bonds to spaghetti noodles, you can compare salt bonds to wooden pencils. A single pencil, although stronger and more durable than a spaghetti noodle, is still easily breakable, but the more pencils you try to break at once, the more difficult it becomes to break them. Disulfide bonds are very strong side bonds that can only be broken by chemicals found in permanent waves and chemical relaxers. Once broken, disulfide bonds can only be reformed by the neutralizing process of those chemicals. Extreme temperatures can also break disulfide bonds, and once disulfide bonds are broken in this manner, they can never be rebuilt. Disulfide bonds can also be broken by extremely alkaline chemicals that are so strong, there is not a strong enough acidic neutralizer to reform disulfide bonds broken in this manner. There are far fewer disulfide bonds in the hair than there are hydrogen or salt bonds. But because they are the strongest of all of the side bonds, they too still account for 1/3 of the hair's total strength. Just as we compared hydrogen bonds to spaghetti noodles, and salt bonds to wooden pencils, we can compare disulfide bonds to wooden baseball bats. A single bat is breakable, but quite difficult. The more bats you try to break at once, the more difficult it becomes. So let's recap. Hydrogen bonds are the weakest side bonds, comparable to spaghetti noodles, account for 1/3 of the hair's total strength. They are the most abundant side bond, can be broken with heat or water, and rebuilt by cooling or drying. Salt bonds are stronger than hydrogen bonds, comparable to wooden pencils, but weaker than disulfide bonds, account for 1/3 of the hair's total strength, are more abundant than disulfide bonds, but fewer than hydrogen bonds, are broken by changing the pH level of the hair, and rebuilt by rebalancing the pH. Disulfide bonds are the strongest side bond, comparable to wooden baseball bats, account for 1/3 of the hair's total strength, are the fewest side bond in the hair, and can be broken only by chemical solutions, and rebuilt with neutralizing chemicals.